All right, everybody. Hopefully you've had a chance to look at the examples and try and work through them. And we're going to go through them together on here. So example 1 says identify the similar triangles. Justify your answer. You can't just say it's those two, although you kind of want to. What they're asking for is you actually have to write these as triangles with corresponding sides. It's kind of what they're trying to ask here. So like STR is corresponding to RQP or something like that. So the way we figure this out is similar to what we did previously. We can identify our longest side and identify it for both. So for our big triangle, we have RS as our longest side. So why don't we start with that? RS, and then we would go to RST, right? That's the only triangle we can make if we start with RS. And let's look for our biggest side here, Q to R, or R to Q, I suppose. That's kind of the decision we have to make. So if we said RQP or QRP, it's one of these two, okay? So let's try the RQP. R to Q is 6 meters. That's our longest side, corresponds to our RS. But RST goes RST. Our second side needs to be our shortest side in this case. So RQP is for our shortest side. Absolutely. So RQP is correct. If we went QRP, so Q to R to P, our second side would be 5 meters, and it's actually our middle length side. So that would actually correspond to T and R, which we don't actually have lined up here. So we know that we can't do QRP, we have to do RQP. So our two similar triangles are RST and, oh, excuse me, RQP are the similar triangles. Oh man, I'm writing like a goon here. Similar triangles. And then we have to justify our answer. So since it is a word problem, you have to answer in a full sentence, right? And justifying our answer, we would say all sides are corresponding. Whoa. When we order our triangles, we'll just do this, triangles this way. Cool. So let's go to example 2. Example 2 says, at a certain time of day, a person who is 1.8 meters tall has a shadow 1.3 meters long. So that's this guy over here. At the same time, the shadow of a totem pole is 6 meters long. This one here. The sun's rays intersect the ground at equal angles. So these are the sun's rays, little dotted lines here. How tall is the totem pole to the nearest tenth of a meter? So what we need to do for this question is set up a proportion. We're going to say 6 meters on top here and 1.3 meters on bottom. We know those are our corresponding sides because they're the shortest length, and we've got our sun across here, or not shortest length, but the bottom side, and we've got our sun's angle here. So we know that those sides are corresponding already, and we're looking for heights. So 6 meters divided by 1.3 meters, plug that into your calculator, and you end up getting a weird number that we're going to round to 4.62. And you're not supposed to round this yet, so maybe I'll give you the whole thing. I'm going to do all that in my calculator though. 61538461154. Kind of a difficult number to work with. And then we're going to set up a proportion, keeping things at the same on the same side of this division. So our 6 was on top, our totem pole measurement was on top. So we go x divided by 1.8. And that should equal 4.61538. Da 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 da. So let's go multiply both sides by 1.8. 4.61538, blah blah blah, times 1.8, and we end up getting something around 8.31. So it says how tall is the totem pole to the nearest tenth of a meter? Oh, should be 8.3. So we say the totem pole is 8.3 meters tall. And there's our answer. Take a look at example 3 here. A surveyor wants to determine the width of a lake at 2 points on opposite sides of the lake, so h to n. She measures distances and angles on land, then sketches this diagram. How can the surveyor determine the length h to n to the nearest meter? So this one has a couple steps to it. We've got the idea that this big triangle and this small triangle are two things that we can work with separately. So we're going to split those up. We'll draw our big one here. Whoa, that is a little off. So this is our triangle H and J. And then we've got our small triangle as well, a little separate. And this is P, Q, J. So this one, we know the length is 210. We know this one is 230. And then we need to figure out this side, because essentially what we're setting up is our corresponding side P and J corresponds to H to J. So we know H to J is 305 plus 210, which gives us 515. So now let's set up our proportion. We go 515 divided by 210. Plug that in. And we get 2.45. We do nearest meter. Okay, so we don't have to be too specific on this. So we'll just round this to 2.45. And if we set up our proportion, we're looking for this one here. We have that one on top. And it corresponds, this one corresponds to this one here. Okay. So 230, and that equals 2.45. Use some algebra, multiply both sides by 230. And we end up getting x equals 5, 5. We'll try this one again. 564. So this is our answer, but the question is actually how can the surveyor determine the length h to n? And the easiest way to answer that question is to talk about what we just did. So the surveyor can set up a proportion between HJ and PJ then they can figure out HN from PQ. That would be actually answering the question. Okay. Um, I think it's useful to figure this out because there will be many questions like that. But, as always in math word problems, pay attention to what's actually being asked. Okay, in our final example, a surveyor used the scale diagram to determine the width of a river. The measurements he made and the equal angles were shown. What is the width AB to the nearest tenth of a meter? So, in the picture, actually, I forgot to put this in. The river is kind of in between or along this measurement. Okay, so this is kind of our river area. And we're asked what is the width. So we're asked what is AB to the nearest tenth of a meter. So we need to set up our proportions, and we need to actually set up which triangle is which. Oh, this should be C as well. That little point right there is C. So this is the kind of example I showed where one of our triangles is flipped around. So what we're going to have to do is figure out AB, what does it correspond to? And what does AC correspond to? So since we have this triangle with the right angle, we could actually kind of flip this upside down. So we could draw it like this. We could flip it upside down, then mirror it. So we actually have, E here. We have D down here, and we have C over here. So I've just turned this one around. And D to E is 98.3. And then E to C is 73.2. I find it a lot easier to work with these when they're in the same orientation, so that's usually what I do first. But let's set up our proportion. So EC is 73.2 divided by 28.9. So for our scale factor, we get 73.2 divided by 28.9. Here's tenth of a meter, so 2.53287, some more. And there's a bunch of decimals to this one. And then we'll set it up comparable with our new proportion. We'll use this as X here. So we have 98.3 divided by X equals 2.53287. So if we use algebra, multiply both sides by X, and then divide both sides by this decimal, we end up having to answer 98.3 divided by 2.53287 equals X. So 98.3 divided by 2.53287. And we end up getting X equals 38.8 meters. So what is the width AB to the nearest tenth of a meter? the width of AB is 38.8 meters. And that's it. Those are our 4 examples. Tomorrow we'll do some practice problems, some practice questions, and you guys can set up any time to kind of talk to me over Teams if you're having issues. Cheers.